A breakthrough for scientists after they had a 20-minute conversation with a humpback whale.
Did it say I'm tired of fish? I'm tired of plankton?
Scientists just spoke to whales, and the whales answered back. Not with splashes or playful squeaks, but with a structured language hidden in the ocean for millions of years. What if I told you AI just cracked the code of whale speech? That deep below the waves, whales have been sharing messages we've ignored. Some joyful, some possibly warnings. In this video, we'll uncover how scientists used AI to decode their language, what the whales might really be saying, and why their words could change everything for us. Cracking the code beneath the waves. It started with a click, not the sharp sound of a camera shutter, but a deep, resonant pulse rolling through the water, bouncing off coral walls and fading into the blue. For decades, these codas from sperm whales have been a mystery. To human ears, they might sound like irregular pops or knocks, but to the whales, there's something much more. Marine biologists knew the clicks weren't random. The rhythms repeated with uncanny precision. Some patterns seemed to identify individuals, almost like a personal name. Others appeared during specific events, pods reuniting, calves calling their mothers, or groups diving together into the deep. And yet, despite decades of listening, no one could crack the full meaning behind them. The problem wasn't curiosity, it was capacity. Decoding a potential non-human language required immense amounts of data and an understanding of patterns too complex for manual analysis. For most of modern science, the process meant sitting for hours with hydrophone recordings, manually creating spectrograms, and making educated guesses. It was like trying to translate Morse code in an alien language without a key. That changed when marine bioacoustics collided with artificial intelligence. Suddenly, scientists didn't have to just listen, they could train machines to listen with them. One of the most ambitious efforts came from the Cetacean Translation Initiative, or Project SETI. Their goal, to build the world's first AI model capable of decoding whale communication. This wasn't just an exercise in curiosity. If successful, it could be one of the most profound breakthroughs in human history, bridging the gap between our species and another intelligent life form right here on Earth. In Dominica, sperm whale recording began in one of the more natural laboratories, whereby stable, multi-generation family groups could be identified, tracked, and studied over the years. Hydrophones were put in place and non-invasive tags, consisting of hydrophones, an accelerometer, and a magnetometer, were used to record whale sounds, movement, and social context. The results were staggering. In a few years, SETI amassed over 50,000 hours of recordings, the largest such dataset ever. But it was not the size alone that constituted the breakthrough. Rather, it lay in feeding this ocean of sounds into advanced transformer-based AI models akin to those that drive human language tools. The models detected not just timely transitions or pitch. They were working on something much more profound, the rules of structure. The so-called codas were not random occurrences of clicks, but rather comprised a structured series based upon concepts such as rhythm, tempo, rubato, and ornamentation. When you map the elements on the pods, they reveal a picture of a communication system that had actually appeared to be more complicated than anyone could ever suspect. They differed between clans, were passed on from generation to generation, and in some cases, displayed a sort of plasticity to reflect changes in the social context, the hallmarks of a true language. It was this insight that now seriously challenged the long-standing belief that the kind of linguistic complexity that would rival human forms would somehow be ours alone. The implication being that 50 million years back, whales have been talking an exceedingly complex and structured language. And with AI finally helping us understand it, one question became impossible to ignore. If we can now hear their words, what are they actually saying? The dialects of the deep. Once AI began pulling apart the building blocks of whale codas, something unexpected surfaced: variation. Not just between individual whales, but between entire pods, regions, and even ocean basins. To a human, the differences might be subtle, like the difference between a British accent and a Southern drawl. But to the whales, these changes in rhythm, tempo, and ornamentation aren't just quirks. They are identity. In Dominica, where Project SETI focuses much of its work, family groups, known as units, have their own distinct patterns. A calf born into one pod will spend over a decade learning its unit's dialect. Older whales model the rhythms, spacing, and flourishes, and the young mimic them until they're perfect. This isn't instinct alone, it's cultural learning, passed down generation after generation. And these dialects are surprisingly stable. A unit's core codas can remain the same for decades, even centuries. That stability means researchers can track entire family lineages simply by listening. A particular click sequence might tell a whale exactly who they're communicating with, much like hearing a familiar voice across a crowded room. But dialects aren't rigid. Adult males, when they leave their birth units to join other pods, often adapt their vocalizations to match their new social group. It's not unlike a human moving to a new city and gradually picking up the local slang or intonation. This level of vocal flexibility points to something bigger, a social awareness of the audience and the ability to intentionally shift communication style. To this point, cultural bartering has drawn parallels between non-human and human languages, and here it becomes impossible to once again state such an obvious fact. A dialect is more than just a physical sound. It fosters a sense of belonging. It unites pods or marks the difference. Thus, the way whales maintain their affiliations is shaped. Some scientists even propose that these variations could play a role in mate selection, conflict avoidance, and fellow pod cooperation. It is AI that has made grasping such patterns an easier task. Identifying a dialect prior to machine learning would require months of careful human analysis, sifting through hours of recordings for subtle variations. Now, within a matter of days, machine learning algorithms analyze massive datasets and flag not only the presence of a dialect, but its evolution over time. And the thing is, evidence suggests evolution is happening at this very moment. The researchers observed slight changes in ornamentation and rhythm in some areas, something that might reflect cultural drift, the gradual transformation of a dialect over generations. In other instances, whales confronted by new pressures, both environment-induced and human-caused, seem to very rapidly change coda production, adjusting to the demands of a new situation. Now, just compare that with the whaling. It is really surprising when you think about it that such huge mammals would be able to do that. Humans change language continuously and create new words, delete old ones, borrow phrases from other cultures, and take them for granted. But in whales, these same processes, the slow churn of cultural evolution, are happening in the depths beyond our sight, but not beyond their hearing.